Hello and welcome to another episode. Sorry for the small vacay we've had in our output. We have been busy in the background, so busy, so much so that we haven't actually posted anything for a little while. We've been absolutely flat out in all aspects, from me doing some more digger driving in my happy place, as you can see here, to concreting. We've been tearing up some more Second World War runway, or taxiway as this is. Lots going on. Lots been going on. Tilt rotator in action. Look, I don't know what we do without the old tilt rotator. I think I could almost say I may have started to master it now. I've got an opposing thumb for this, but we don't use it because the tilt rotator is just as good with the old Scandi bucket on. This doesn't look dodgy at all. It's all within the safe confines of the operation of this machine, obviously. At a level. Oh, look, there's my dad. I've had to drag my dad in, draft him in, pull him back from retirement. Classic Blake look. There you go. Here we are, just putting a bit of foul in to poo pit number 1 or poo pit 2, depending on which direction you're going in. And yes, we've been doing a bit of concreting, or getting ready to supposedly subcontract some concreting out, but that's a whole other story that we won't go into. But this piece of reinforcing here might actually not be here in a few weeks' time, but we'll not go into that. And here we are, taking delivery of some more cable. Evan is in his absolute element as he drops into the man, the professional, the legend that is Evan the electrician. Mr. Perfectionist, take it away.
Hello and welcome back to another episode of Blake Builds on the BIR Developments YouTube channel. So, exciting, we're finally in the building. Well, I say we're finally in the building, I don't mean we've moved in, I mean we're finally able to come and work in here. So we've got the floor all concreted, we've got a nice open empty space for us to work on all of the fit out. So this means all of the electrical stuff, all of the M&E package, so M&E, mechanical and electrical. Electrical is what it says on the tin, that's power and lighting and things like that, and then mechanical is like heating, ventilation, air conditioning, plumbing. There'll be a little bit of cool stuff to see when we put the MOT ramp in and all of the ramps for the vehicle servicing workshop, which we're now moving into this building 1 temporarily because there'll be some air lines and things like that to install. But yeah, mostly it's electrical in here. I've done some drawings and we're going to make a start on actually prepping a lot of the stuff to get all of the cabling installed. Something I've been looking forward to for quite a while. Obviously, this is my background, is electrical install amongst other things. Over in this corner here, you'll see I've already made a start on some bits, but over in this corner, we brought all these ducts through in order to accept cables that go to access boxes outside, and they will feed things like lampposts or EV chargers or anything we want to wire outside. Basically, those ducts are the interface between the inside electrical installation and the outside. We've got National Grid coming on Tuesday, and the cable that they laid and left outside the building, just out there, they're going to join onto that and bring it up and through here, and then they're going to mount what you'd call a cutout here. It's a big enclosure, and they'll have the cable come up and there'll be connections at the bottom, and then there'll be a load of fuses inside. There'll be big fuses. I think they're 315 amp fuses in here. So we've got a number of boards. When I say boards, I mean what you might call a fuse board. In this case, they're called like distribution boards, or DBs for short. People call them DBs. Yeah, we're going to have a number of boards here. So I've done a bit of a drawing of how I want to lay it out. And just to kind of talk you through what each of these things mean. So we've got a distribution panel here, which is going in this corner, and that is an MCCB panel board, which stands for molded case circuit breaker. So it'll have big circuit breakers in, basically much bigger than you'd see in your house, and this is strictly being used to feed all of the different distribution boards that we're going to have in this building. Now there are only three. We've got a lighting board and a power board. You think of it from a topology point of view, we'll have National Grid, they bring their cable in, and then it goes into a meter, which will be, say, Eon or M-Power or whatever they're called these days. And then out of there, we'll have an isolator, and that will then connect to our MCCB panel. And out of the MCCB panel, we will feed each of these distribution boards. So here we've got a power board, which is going to cover things like sockets, and it's going to cover things like the MOT ramp and anything that is electrical but not lighting, basically. Then we've got the lighting, which is, again, as it says on the tin, that's going to do all of the high level lighting. It's going to do the emergency lighting that goes around. It's going to do some canopy lighting outside. And it's going to do some sort of walkway perimeter lighting outside the building as well. And we're going to put a metering box in above, so we can have separate meters for these two boards to see how much power or energy we're using from the power side of things, from the lighting side of things, and it will help us just break down to sort of a real granular level what energy we're using and where. So we're also going to have a board down in the bottom corner, a distribution board that will feed the JIT area. Because when we first spoke about doing this building, our ambition was to make it so that we could break it up into different bays and sections so that we could rent it out if we wanted to in the future. And that's why we've done things like, you know, we've put a foul soil stack in at multiple places across the back of the warehouse. Because then if we wanted to divide it up, for example, into 2 bays here, 3 bays here, 2 bays there, you could rent these out individually. If you put partitions up, they would have the services required to act as sort of self-contained units, if you like. And this is kind of a good test run for that, really, by putting JIT and Vale in the same building, because Vale, the vehicle servicing workshop, will all be fed from the distribution stuff that's down there, but we'll have an additional distribution board down there just to feed the operation that's going on for JIT. Here we'll have a circuit coming out that goes to the lighting, we'll have a circuit that goes out to the power, and then we'll have a circuit that goes out to the JIT board. So these are all your other DBs, like that. And you'll have your individual circuits coming off there. You know, for example, this is a 24-way TPN board, 3-phase and neutral, which means that we're going to have 3 times 24 ways in there, basically. What's that? 72 ways. 72 single-phase ways, and I'll talk you through. In fact, I think we did a little bit on 3-phase and single-phase back when we were doing the substation installation. So the first thing that I've got to do really is get an area set up where National Grid can put their cutout. They could just plonk it there and then like put their cable in and it would just go wherever they put it. But I thought if we can control where it goes, we can make it look nice and neat. So I'm using this stuff, which Ollie and Ben like to take the mick out of me for, because I love the stuff. We're using this, which is called Unistrut. It's like big adult Meccano, basically. It can hold an absolute ton of weight. You've got these different fixing systems that we use. So here we've got, this is called a sprung channel nut, but everyone calls it a Zeb. It looks like Zebedee from the Magic Roundabout. The spring holds the channel nut in to the channel. So you push it in and twist it like that, and the tension of the spring pushes that nut up against the edge of the unistrut. And then when you want to fix something to it, say like these L brackets, for example, you can just get a bolt and a washer like that, and the nut is held in place, and you can just screw it in like that. You don't have to put your, you get your hand underneath to get a traditional nut in place like that. The channel nut holds itself in place, and it's specifically designed to be used on unistrut. When you've got limited amount of space in the top of the distribution board, it means you can only make off so many cables. So what you tend to do is you tend to wrap the board or the boards in trunking, because it gives you a much wider space to make the cable off into, and then you can take all the cables inside and you can slot out the inside of the trunking and sit the distribution board underneath it or on top of it. In this case, we're going to sort of sandwich the board between trunking. It just gives you some more space to work, and it can lead to a neater job, really. So that's what we've got on this drawing here. So we've got 225mm Galv trunking at the bottom, 225mm at the top, and then we've got some 150mm by 150mm bits of trunking that go in between each of these boards. Watch me muddle through this for a little bit, and hopefully I can talk you through some bits along the way. I'm going to fix these up here like that, and these L brackets are going to fix to the back of the strut and just hold it up against the purlin, and then we'll fix them down to the floor. I'm going to do one at the top, one at the bottom. That'll be a real sturdy frame then. And this is the electrician's best friend, the laser level. Another sunny day in Langer. I don't know how we keep doing it. The weather's on our side. I think it knows that we're on the home stretch now, but we really are pushing. So we just got to keep going. But National Grid are back, look. So they're just making this termination now, going from a 300 to a 185. Just a short bit of cable. It's orange because it's LSF, so like low smoke and fume. So basically if the insulation burns, it doesn't let off any nasty toxic stuff. And then I've made a little unistrut frame for them to mount on, which they're just doing now. So this is our 315 amp per phase cutout. So we've got this cable coming in, 185mm cable, and it is solid aluminium. You can see that there. Solid alley, and these are shear off bolts. So what they tend to do is install, I mean you can't really see now because he's put these on, but the alley sits in that little bit there, in that little holder, and then they put those bolts on, and these bolts shear off on the heads so that they know that the torque setting's correct. And you can see here the head's sheared off, so it's all torqued up and nice and tight basically. And then I'll come out the top here, this little sort of grommet strip, put a bit of trunking across, have an isolator there, big isolator, out the bottom and into our boards here. So they're nearly done now I think, but I'm going to leave the chap to it.
So, an update on the floor slab from a previous episode. Obviously you see the joints that were cut into it to allow for the expansion and contraction of the slab. When you saw the alpha joint which we put in, which was the in situ kind of movement joint which stays in the slab, which was two pieces of metal sandwiched together that were tight together when the concrete was poured, but you look down here, you can see as the concrete's cured and dried, it's shrunk and it's pulled two strips of metal apart.
Wow.
So it's quite a gap there now.
Isn't it?
So if these movement joints and saw cut joints weren't cut and put in the slab would have literally teared itself apart and cracked wherever. And it's always going to crack. Concrete will always crack. It will always need to expand and contract, but it's about trying to keep those cracks where you want them, so you can direct them in certain places, like with the saw cut joints. Adds a weakness that it'll crack down, and these expansion joints allow it to expand and contract that way. But a really good example over here of what the saw cut joint does because it's quite rare that we get to see the side of the slab, but because we've got this recessed MOT pit, we can see the side of the slab, so we can actually see the side profile of the saw cut joint. So if you look here, you've got the saw cut joint there, but exactly as designed, it's cracked further down there. So below the saw cut joint, you've got the crack following on down.
And that's okay, is it?
That's fine, that's exactly what's supposed to happen.
Right. It encourages it to crack fully there.
Yeah, so rather than this cracking somewhere else, it cuts under this saw cut joint, and when this saw cut joint will get sealed, and then you'll never see it then. But you can see over here, you can see just how much it's opened up. I don't know if you can see on the thing, but you know, that's the saw cut joint was only going to this point here, and that concrete is opened up, you know, a good 3 or 4 mil.
Yeah. Along that same line.
Along that same line. So it's important. It shows the importance of putting in these movement joints to allow the concrete to move. And then what it will actually do throughout the different seasons and throughout the year, as it gets hotter and colder and humidity changes, it will expand and contract. It will close and open. These joints will, which is why you have to put a flexible sealant in them. But yeah, just a good example there of why we do it.
Sandwich van.
Sandwich van.
These are some of the brackets that we've been making. And these are out of the shallow unistrut, which is the 21mm by 41mm. We've got the little channel nuts in there. You can see I've mounted a bracket up there, just as a bit of a tester. You see it, that bracket there, dangles down. So that's going to have all of this stuff on this cable tray. It's going to sit on the brackets, and we're going to have some 300mm, some 150mm, a couple of bits of 50mm, and that's going to run all the way down the middle of the building. And we'll have one of these G-clamps on one side, and that just hooks over the purlin, that bit there, and then you tighten it down and tighten that nut up, and then you have a couple of nuts either side of the G-clamp as well, and we'll tighten those up just to stop it slipping anywhere, and they go through the bracket. We've got a series of little washers, got a little penny washer there, square plate washer, same on the other side, and it just sandwiches it in place. And on the other side, we're going to drill and bolt through the purlin with these L brackets here. And then I've made some more brackets up. It's bracket central around here. Got these are at 1800, and we're going to put those, or I'm going to put those up here on this black steel, and I'm going to hang them on one side off the purlins, and on the other side we're going to fix them up with these things, which are called window brackets. Quite a clever bit of kit. They just slide in like that, and you can tighten up against the steel flange, which will sit in there. It just holds it in place. put this on before. Minimal filing required. Just makes a really nice, neat cut. It's ever so quick. There is a really good tip for this as well, for spraying unistrut that I learnt it from Residual Current, which is a YouTube channel, electrician YouTube channel. He basically does like a pool of it. You usually do it in the can lid, and then you just dip your unistrut in the end like that, and it coats the end without the spray going everywhere. Very clever. It's a very exciting day for a nerdy electrician like myself, because we've had all of our distribution boards delivered. This bad boy. Da, 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 da. This is our panel board, our distribution panel. And this is where the main switch goes. There's a big old main switch that goes in there. So this 24-way TP&N 3-phase and neutral board, that's this. Here's one I've stripped down earlier, and I've taken the bottom bits off. And so you can see they come with this pre-formed cutout. This is by a brand called Hager. Really high quality bit of kit. Used Hager quite a lot in my career. Very, very good stuff. And they've got this nice sort of glass finish on the front, well, perspex, but you can see through to each of the breakers. Where it says 24-way, it actually means 24 3-phase ways. So L1, L2, L3. So you've actually got, what's that, 72 single-phase ways there. Goes all the way up to 72 ways. So sounds like loads and loads, but you end up using those circuits up quite quickly. My idea is that I want to get all of the boards laid out on the floor and get the trunking marked up so that I can make my holes where I need to make my holes, and I can set up for other bits of unistrut that might need to go up to help support all of the boards when we mount them. And it also just gives me an idea of, you know, a physical representation of what I've been drawing. I've drawn it on AutoCAD, but it doesn't always reflect actually what's going on in real life. And some of the challenges that you come up against when you're doing this sort of thing are getting everything square is actually surprisingly difficult. I've got some trunking going in between each of the boards, and I've got a big bit going in at the bottom, a big 225 by 225 bit going in at the bottom, and I've got 150 by 150s running in between the boards. Then we're going to have another 225 across the top. But in between those, you tend to space off the boards with this stuff called Paxolin. It's like a fireproof board, composite board, that sits between the metal trunking and the distribution board. Space it off a little bit, and also means that when you pull the cables through, it's a softer edge to pull the cables against rather than against metal. Or you could maybe use grommet strip or something like that, but Paxolin is like an industry standard and recognised material to use in between your trunking and your boards. So what I've done is I've just laid everything out, and I've spaced out using these little square washers that we've been using on the strut for the brackets, because they're about the same thickness as the Paxolin. And the reason you need to do that when you're setting out, A, is to account for that material, but also when the boards open and close, they just need a little bit of room all the way around, because this trunking is going to protrude out to here. So you do actually need to space everything off a little bit, and I've done the same down the bottom as well. you don't want it really tight to the trunking because you just never get it all in. So first step is just laying everything out, roughly marking things up about where I want to start cutting some holes and things like that. And what I really want to do is I want to make sure that if ever we want to add to this installation, we've got maximum flexibility. So you can see these, I've taken the top plates out of these boards and the bottom plates, so cables can come in from the bottom, they can come in from the top, and they can come in from the side. And it just makes the life of the next person so much easier whenever you want to add anything. Obviously we're doing like bare bones installation for this at the moment, partially because of time, partially because of money, but also it's only a warehouse, so it doesn't need to be all singing or dancing.
Hello. And time doesn't matter on YouTube, does it? And I'm sure in a few years' time, when we look back on this, when we're older and greyer than we are now, the fact that it's a Friday morning won't mean anything. But it's a Friday morning here, and it's an exciting day because we're having our doors fitted. So these chaps are here from Tick-tock, and they specialise in good high-speed doors, insulated panels. You see a lot of warehouses. Our existing warehouse has a roller door, sectional panels, and this is a sectional panel, insulated sectional panel door. Which, if you follow me up here, one we did earlier, they've actually put the end one in yesterday, and yeah, we've got a term that's probably not YouTube friendly, which is awesome, and it is definitely awesome. You'll have to beep that out, but yeah, they're wicked. They're really cool, and they've got a window in, so you can look out through them. So these lovely gents, I can show you what they do, man. So there we go. And these lovely gents basically building it all up, putting all the brackets on, and some guide rails to put up. And we're reliably informed that our steels are nice and straight and level. Perfect. So yeah, attention to detail all the way along does have an impact actually. You know, when we were prattling about with all them bolts in the ground, because we've put the building up dead plumb, dead straight, dead square, actually every step along the way from that has been easier really, because you can just bolt to it. Let's have a look at this one that I've done there. These are actually high safety doors, so there's actually a sensor in this rubber at the bottom. You can see the wires there.
Yeah.
So that it'll stop if it hits anything.
Oh, that's cool.
And they will move relatively quickly considering what they are, if you know what I mean. They're quite a fast door. And there's some photo cells at the bottom and, you know, all that sort of thing. So it's, and they don't roll as a lot of roller doors do. It goes up and it matches the picture of the roof of the building.
That's nice. Is there any benefit of having it not roll up, you know?
Just so you can have these bigger panels, and because you can have these bigger panels, they're insulated, you see, so
I see.
you've got an insulated panel and they interlock together. It's quite, as they roll down, they actually like tongue and groove into each other, which is great. And then me and my dad actually have been fitting the doors, fitting the pedestrian doors, which is like a pre-made steel fire door.
So I'm going to start cutting the trunking down, drilling some holes, getting it mounted on the wall. Pressure's on. There's a 150 by 150 trunking, one of those that goes up like that. Another one here, another one here, another one here. And I've just marked where they're going to go. And I'm going to cut that out so that we've got an entry for the cable. So I need to cut this strip out. Cut this strip out, because this is where the power board is going. And then we've got the lighting board here, and that's the cutout for that. So it would be quite difficult to get a jigsaw in just to get this last bit off. So what you can do is, you can file this bit off, file it down, and then you can just flap it about and it will bend off and leave a nice neat line.
This is my father, Philip.
Also an avid follower of the channel.
Average follower of the channel, yeah, so don't forget to like and subscribe.
Nice. Nice. That's brilliant.
And it's all my fault, sorry.
I suppose it is, generally.
Yeah,
isn't
it's
it?
all my fault, yeah.
When you get down to the nitty-gritty of it all.
Yeah.
Taught me everything I know, but still know nothing.
Yeah.
Simple system. These adjusters screw into the frame, and then you can adjust it out when you get it in the gap. So you need a tight fit in your hole, don't you? We're talking about holes again, aren't we? Call it an opening. Oh, I don't know if that's any better, to be honest. These doors are designed that they can, yeah, so you wind them in and out, and you can actually get to them from the inside. So when you put it in the opening, you can adjust them out. Like I said, the only slightly disappointing thing is there's brackets for both sides of these, like this channel, but the size of opening we've got only allows you to have channel one side. So. The only thing is the threads aren't the best. So, and I have got a tap over here for cleaning the thread out, but even cleaning the thread out don't seem to help, does it?
No.
That is a tap, if you're interested. That's for cleaning threads or tapping threads. And I've tried doing it. So that universal fit, so you can actually, depending on, they're the same dimensions both ways, so you can hang them that way so that it opens like that, or you could hang it the other way up and it will open the other way. There you go.
Are we going to try it from the inside or go outside this time and try it?
Just go straight from the outside. I'll just make sure it fits. And just make sure that it will do, I'm sure. Because we made all the openings.
Well, we've got concrete here, haven't we? We haven't had concrete.
Yeah.
Oh, that it's been raining.
I'm just checking the height to make sure it will actually fit. We've had a couple that have been a bit tight on the height. So this is the header spacer piece that goes on the top of the door. And I've got to cut the width because obviously that's not adjustable. Mm-hmm. So and we do everything from the centre so that you can still get to those adjusters in the top. So it's 1140 long. Half of that is 570, so I've marked the centre line, and then it's 1195 is about the door, I think 990, something like that. So half of a metre would be exactly 500 mil, so we just go under that, a little bit under that. Using a square, transfer that line all the way around. What a wonderful tool a square is. It really is clever. Simple. Like all the best things in life, the simplest of things is always the execution. Bandsaw. Absolutely fabulous bit of kit. Good for cutting your fingers. Fabulous for cutting through material like this. The only thing is it's quite difficult to get it dead straight, that's all. I think historically you'd have probably done this with a grinder. And there you have it. And so now that will go, that fits in there. And if you're thinking, oh, it's a bit loose, that's because there's sealant and flashing to go around it. Done on purpose.
I was wondering.
Wait. Cool. Yeah, just hold it there and then I'll put the edge piece on and the header piece and we'll push it out.
Okay, back a bit.
And you see how that'll work then? So that's actually gonna, from the inside when the door's open, you can wind them out and that will then push that out to fit the door open.
You want me the other side?
Yeah.
Yep. You there?
Yeah?
Yeah. Go on. Oh, hold on. It's catching on a rivet here, on the top plate. Okay, got it now. Yeah, go on, go on. Yep, okay. Yeah, nice one. Keep coming, keep coming, keep coming, keep coming. Keep coming.
How's it looking?
Yeah, it's pretty good actually. Want a little bit more just to level it up. Just
Okay,
meter
we'll
or
get the
so.
door open now, shall we? Ready for the first opening?
Oh, yes. Ooh.
Hello.
Behind door number 3.
Yeah, there's no prize today, I'm afraid.
You are the prize, Phil.
You want your money back?
Yeah, that's it. Is there a guarantee? No.
Oh, yeah.
How's it going?
Yeah, fine. Right, we'll just work it to the edge then, shall we? Yep, and just wind them out a bit. So that then winds out and shuts the gap up. Don't go too much because you actually have to wind the door over. And then there's a small gap here down this edge, but they'll get siliconed in anyway. So, oh, that's perfect that side. Isn't it? I'll open it up. I'll get them fixings in there.
Okay.
This one so far.
Number 4 of this one so far. Yeah, we're getting quite good at it. One took 2 hours, and then the other one took 15 minutes.
Tech screws, which you've seen lots of.
Yep.
And they actually go in the centre of those mushroom bits that I wound in. You know that I was adjusted.
Yeah.
They actually go in there, and then they fix into the aluminium.
Oh, wow.
So it's a really simple. That's it. Amazing, isn't it? And actually, it's really strong because it's into that good strong aluminium behind that we put in the closure alley.
Yeah. Yeah, sweet.
So that's actually, it looks bloody horrendous from this side, doesn't it? But that's how it works in builds.
Will there be an inner? Yeah, you'll have panels here, won't you? Or do you?
You wouldn't ordinarily, but we're actually going to put our sound deadening on there. So trying to have a holistic approach to what we're doing. So unusually, we're actually putting acoustic management in this warehouse. Right, shut that around then, PB. That's how I fit a door, whether that's correct or not, I don't know. But I've bolted a pedestrian door in.
Well, it's in now, isn't it? It's good.
That's it, that'll do.
I'll do. 4 of 4. Congratulations.
Thank you very much.
Power time, baby.
It's power time.
It's power time. Welcome to Power Corner. So, got all the boards like connected up. Little proof of concept, just make sure that everything's going to fit and everything's square. We had the issue with the doors opening, the paxilling that we put in between this board here. You see this little bit that's sandwiched in there. Wasn't quite thick enough to allow for the doors to open on these two, on the power and the lighting board. So I swapped them out for these bushes and couplers. The bush is the brass bit. That looks like.
And we all love a good bush, don't we?
You get bush like this, which is a bit on the end that you can put either a socket on
Threaded
or
brass.
Yeah, it's just a threaded brass 2-inch thing. You get long ones, short ones. This is a short bush, short 50mm bush, and you get a lock ring as well, and that just helps space it off, tidy it up, neaten it up a bit. And then you put your coupler in between, which is a threaded tube, and same on the other side. So that allows a cable entry in and out of the board, and you want to make that entry as smooth as possible, so you don't want any jagged edges. So this is a really nice nice rounded off bit that you can pull cables through. And I've put a load in because you want to be able to get in and out from every which direction really. So we've got holes in at the bottom of each board, and that is going to be the power to supply the main switches. So this is just a main switch, it's not a breaker or anything, it's not a circuit breaker, it's simply an isolator. It's a 4-pole isolator, which means it isolates live, neutral and, well, the three live phases, L1, L2, L3 and neutral. And then we've got a surge protector there as well. So in case of any over voltage that comes from a lightning strike or whatever, we have got lightning protection on the building, but that'll also protect all the services from getting blasted. You see this black stuff on here, this is called grommet strip. I cut the hole in the top of this big 225 Galv trunking ever so slightly smaller than the 150 trunking that goes in between, because there's nothing worse than seeing gaps all the way around your trunking.
And what's the purpose of the grommet tape?
Exactly the same as the bushes, so it's when you're pulling cables through, you're not snagging that insulation.
You don't want any sharp edges?
No, so everything's filed and Galv sprayed and grommet stripped where necessary, and then the Paxolin offers another. That's kind of similar to the grommet strip really. The Paxolin just offers that smoother edge for it to come up against. We'll have to run a bit of grommet strip around here. Yeah, so next phase now is I've measured up between these fixing holes, and we're going to put some vertical struts in. I'll put a couple up over there, but they actually need moving over to the right a bit. I've started to fix the legs down to the ground now because we've had the anchor bolts turn up. So they're all nice and sturdy. So next step really is disassemble this, get the boards mounted, get the trunking mounted, bolt it all together, you know, bit by bit in situ. Put the header trunking on, which is another one of these but across the top. So you're going to be able to get in and out of all of these boards really easily with cables. There shouldn't be any requirement to drill or anything in the future. And then we can start getting the tray up in the ceiling. And that's what Ben started doing. Those brackets that you saw me fabricating the other day, Ben's putting those together and leveling them up and actually fitting them up on the purlins now. So he's got them all laid out over there. Happy with what you're doing?
Yeah.
Boring, isn't it?
A little bit.
It is boring.
We definitely need some like tunes on or something.
Need the beats on. Yeah.
But it's like a giant Meccano set, isn't it?
Yeah. Yeah, I think this is a fun bit of.
And it looks excessive now, doesn't it? But it's all about allowing for the future, potential future use of the building. Exciting.
It is exciting, yeah.
Time's ticking. Cue countdown.
You count down. How many days is it?
I don't know.
Not enough.
next time on Blake Builds.
So we're back at it, and we're back out the other side. You may have seen in our episode Pipe Inspectors that we found a pipe down there that we were going to reuse. We've got AD Medicine with us to use his trencher to dig it through.
So we've been putting this header course of block pavers down. This is going to be a block paver path just to allow access around the building.
Hello, Ben.
Hello. Welcome to my hole.
Welcome back to the roof. We are currently guttering.
Look at all this that we've done.
I'm an electrician today.
Oh, nice.
I got you.
I don't know what it is with this, it's just like